Welcome to another episode of Kafka Internal's interview Crashcasts. I'm your host, Sheila, and today we're diving into the core components of Apache Kafka. We'll be discussing producers, consumers, brokers, topics, and partitions. Joining us today is Victor, a senior backend engineer. Victor, thanks for being here.
Thanks for having me, Sheila. I'm excited to discuss Kafka internals today.
Great. Let's jump right in. Victor, can you explain the core components of Kafka, such as producer, consumer, broker, topic, and partition?
Certainly, Sheila. Apache Kafka is a distributed streaming platform, and understanding its core components is crucial. Let's start with the basics. 1. Producer. This is the component that publishes or writes data to Kafka. 2. Consumer. This reads or consumes data from Kafka. 3. Broker. A Kafka cluster consists of one or more servers called brokers. 4. Topic. This is a category or feed name to which records are published. 5. Partition. Topics are divided into partitions, which allow for parallel processing.
That's a great overview, Victor. Let's dive a bit deeper into each component. Can you tell us more about the producer and how it interacts with Kafka?
Certainly. The producer is responsible for publishing data to Kafka topics. It works by sending records, which consist of a key, a value, and a timestamp, to the Kafka cluster. Producers can choose to send records to specific partitions within a topic, or they can let Kafka handle the distribution of records across partitions.
Interesting. And what about the consumer? How does it work?
The consumer reads data from a Kafka topic. Consumers are typically part of a consumer group, which allows for parallel processing of data. Each partition is read by only one consumer within a group, ensuring that data is processed in order within each partition. Consumers keep track of their position in each partition using offsets, which are like bookmarks, allowing them to resume from where they left off if they're restarted.
That makes sense. Now let's talk about brokers. You mentioned that a Kafka cluster consists of one or more brokers. Can you elaborate on their role?
Absolutely. Brokers are the backbone of a Kafka cluster. They're responsible for receiving records from producers, assigning offsets to them, and storing them on disk. They also handle requests from consumers to fetch data. One broker in the cluster is automatically elected as the controller, which is responsible for administrative operations, including assigning partitions to brokers and monitoring for broker failures.
Great explanation. Now let's move on to topics and partitions. How do these two components work together, and why are they important?
Topics in Kafka are like categories or channels where data is published. They're similar to tables in a database, but with the added benefit of being able to handle real-time data streams. Partitions are where the magic happens for scalability and parallelism. Each topic is divided into one or more partitions. Partitions allow Kafka to distribute data across multiple brokers, enabling parallel processing and higher throughput. Each partition is an ordered, immutable sequence of records that is continually appended to.
That's a great explanation, Victor. Now let's dive a bit deeper. Can you explain how partitions contribute to Kafka's fault tolerance and high availability?
Certainly, Sheila. Kafka achieves fault tolerance and high availability through partition replication. Each partition can be replicated across a configurable number of brokers. This replication is key to Kafka's durability. One broker is designated as the leader for a partition, handling all read and write requests for that partition. The other brokers become followers, passively replicating the leader. If the leader fails, one of the followers will automatically become the new leader. This ensures that data remains available even if individual brokers go down.
Excellent point about fault tolerance. Now, let's consider some edge cases. How does Kafka handle scenarios where a producer is sending messages faster than consumers can process them?
That's a great question, Sheila. Kafka is designed to handle such scenarios gracefully. When producers send messages faster than consumers can process them, Kafka doesn't slow down or block the producers. Instead, it continues to accept and store the messages. Kafka maintains a retention period for messages, which can be configured based on time or size. As long as the consumers catch up within this retention period, No data will be lost. If consumers fall too far behind, they can always reset their offset to start processing from an earlier point in time. Additionally, Kafka allows for easy scaling of consumers by adding more consumer instances to a consumer group. This allows for increased parallelism in message processing, helping to handle high-volume scenarios.
That's really helpful, Victor. Let's summarize the key points we've covered so far. 1. Producers publish data to Kafka topics. 2. Consumers read data from topics and are typically part of consumer groups for parallel processing. 3. Brokers store and manage the data, with one broker acting as the controller. 4. Topics are categories for data, divided into partitions for scalability. 5. Partitions enable parallel processing and are replicated for fault tolerance. 6. Kafka can handle scenarios where producers outpace consumers through retention policies and consumer scaling. Is there anything else you'd like to add about how these components work together in a Kafka system?
That's a great summary, Sheila. I'd like to add that the interplay between these components is what makes Kafka so powerful and flexible. Producers can choose to send messages to specific partitions based on keys, allowing for ordered processing within a partition. Consumers can be grouped to read from multiple partitions in parallel, increasing throughput. Brokers manage the storage and replication of partitions, ensuring data durability and availability. It's also worth noting that Kafka's design allows for easy scalability. You can add more brokers to increase storage capacity and throughput, add more partitions to a topic to increase parallelism, or add more consumers to a consumer group to increase processing power. Lastly, Kafka's architecture enables it to handle both real-time streaming and batch processing scenarios, making it a versatile solution for various data processing needs.
Thank you, Victor, for that comprehensive explanation of Kafka's core components and how they work together. This information will be invaluable for our listeners preparing for Kafka-related interviews. And that wraps up our episode on Kafka internals. Remember, understanding the core components, producers, consumers, brokers, topics, and partitions is crucial for working with Kafka. We've covered how these components interact, Kafka's approach to fault tolerance, and how it handles high-volume scenarios. Thanks again to our guest, Victor, and thank you all for listening to Kafka Internals Interview Crashcasts. Until next time, keep streaming.